Hello. Hello. My name is Christy Person, and this is my final project slideshow presentation about the insurance quoting system I call SmartQuote KS. Welcome to this presentation of my system analysis and design portfolio project. Today, I will walk you through the development of an insurance quote system enhanced with machine learning, highlighting our use cases, diagrams, requirements, and critical evaluation criteria, with the goal being of understanding our key functions, concepts, and challenges of the system analysis. This project focuses on transforming a traditionally manually process, providing insurance quotes, which is used to be done via phone, fax, back and forth email, and on occasion postal mail, changing that process into an automated system enhanced by machine learning. The goal? To provide efficiency and accuracy, providing customers with quick, fair, and personalized quotes, and providing agents with a simple, easy-to-use workflow. The industry are our insurance customers and insurance services. The business goal is to improve the speed and accuracy of insurance quote generation, with our key pain points being manual quoting processes are sometimes slow and inconsistent. And the solution to this would be to integrate machine learning to automate and personalize the quoting system. To meet business goals, the system must be fast, intelligent, user-friendly. Technically, this means integrating machine learning, securing the system, and building a responsive backend for handling the quotes. So our requirements overview are both business requirements with the request to provide a quote in under 2 minutes, support agents with accurate prediction data, and increase customer satisfaction and conversion rates. And our technical requirements are just to use authentication and safety when we're using this process. The main use case focuses on the interaction between the agent or customer and the system. The user submits data and the machine learning model provides a quote. User stories help us refine this interaction from both the business and technical sides. The main user story here that we chose to present is, as an insurance agent, I want to generate accurate quotes using customer data so that I can increase my closer rates. This sequence diagram shows the internal steps when a user requests a quote. It illustrates how the front end, back end, and machine learning components work together from user input to ML prediction to displaying the quote on both ends. The customer requests a quote and their quote is generated, provides the information for them. The agent provides a quote and they prevent prediction acceptance analysis. That prediction acceptance is not provided to the customer. It's only provided to the agent. This class diagram outlines the structure of the system, focusing on how quote requests and machine learning models are organized. And you can see here that the relationship between entities between the entities like request quote, ML model, and prediction results, how those relationships are related and how they fit into the system that we're trying to design. This data flow diagram shows how data moves through the system. And this includes how user input is validated, how the data is sent to the machine learning model, and how results are stored and presented within the model. There are some areas that needed special attention, and we had to address critical issues in order to move forward with the project. Scalability is an issue that the system must handle large user volumes without slowing down. We anticipate this to be a very popular system once it goes live in production, and we need to make sure this system does not crash with the amount of volume that we anticipate getting. We simulated traffic and ensured that 90% of quotes are returned within 2 seconds to the customer. We are still working on data on the prediction model that is returned for the agents. And for vulnerability, we wanted to make sure we protected the system from attacks using authentication, IP filtering, input validation, and role specifications so that we know which users or which players are responsible for which parts. We also implemented multi-factor authentication to ensure that we are staying on the highest level form of security for both our customers and our agents. And the two areas, of course, that needed the special attention were scalability and vulnerability. And these were addressed through load testing, firewalls, and robust API security. And these are crucial to delivering a safe and scalable product. So, in summary, this project gave me hands-on experience in both business and technical domains. Going forward, the plan is to test the model with real user data and continue improving the interface and predictive accuracy. This project provided deep insights into system analysis. We were able to apply real-world tools like Draw.io and MLflow. And the next step is to continue implementing different phases of the project to make the plan and make the system more accessible. And so, in conclusion, this project provided a lot of valuable opportunity to bridge the gap between business objectives and technical implementations. By working through this insurance quote use case, I gained practical experience designing a system that meets both user needs and back-end performance goals. And looking ahead, the next steps would be to involve bug testing, implementing different phases of the project to make it more accessible and more visible and more easy for all of the players to use, both customers and agents. We want to test the machine learning model with real-world production data and real-world production instances, and continue to refine the user interface for greater usability and enhance the system's product capabilities to deliver even more accurate and efficient quote results.